Welcome to the Developer Servers YouTube channel. On this episode, we're going to be continuing our Pong game that we started last week. As you can see, I can play the game and I'm controlling both the left pedal and the right pedal with the keyboard. So in this episode, we're going to be implementing the AI control for the right pedal so that we can play against the computer. We're going to be doing that with several levels of difficulty, ranging from the AI never misses to the AI misses occasionally, and other algorithms that we can implement for that. So let's see how we can do that. Once again, we'll be following the tutorial that I've written in the blog post, developing a traditional Pong game using PyGame, incorporating an AI component. I will leave a link in the description for the blog post and also for getting the source code. So our first implementation is called the hard mode implementation, because pretty much it's an implementation where the AI tracks the movement of the ball and there's no chance that it can miss. So let's see the code for that. I'm going to copy the code from the blog post. We're going to need to be making two changes. First, we're going to be implementing a new function, which I'm going to implement here, AI movement. So this function receives a paddle in the ball. It tracks the paddle position, the paddle position and the ball position, and adjust the paddle so that it matches the ball position. The same for depending if it's on on the top or on the bottom, depending if the ball is not matching the paddle position. And obviously we ensure that it's inside the screen bounds. But besides implementing this new action, we also need to change the way that we control the right pedal. Before it was being controlled by the keyboard, up and down keys. We're going to be replacing that now with calling the AI movement, the function that we implemented before, so that the pedal can move autonomously. So let's try again to play against the computer. So I'm controlling the left pedal with the keyboard. I stop moving it, and the right pedal is controlled by the AI. You can see that it's always centering itself in the position of the ball, regardless where the ball is, and that makes it extremely difficult to play against this AI because pretty much keeping track of the ball position, it will never fail. So let's see what other implementations we can do so that it makes it easier to play against the computer. So our second implementation is called How Can AI Miss the Ball? Because we are going to give a percentage of chance that the AI actually misses the ball. So let's copy from the blog post. So we'll just be replacing the contents of the AI movement function that we defined previously. Again, it still receives a paddle and a ball. We're defining a constant, which is the percentage of chance of the AI making a mistake. In this case, we're defining 15%. Again, we're making sure that it stays inside the screen bounds, but we're checking with random. We're checking the possibility of the AI making an error. And again, with the error, with random, we're establishing if that means that it makes an error for the top of the pedal for the movement on the top of the screen. If there is no error chance, then the pedal just moves to the center of the ball as the ball position as previously. So now let's see in action playing against this level of AI. So as it is defined, I'm playing on the left side. As the AI is defined, it has a percentage of missing. As you can see, just before that it did miss it. It will miss now again, but that's a very low percentage. So there is also a possibility that still hits for most of the times. Of course, you can adjust the error percentage. For example, you could have defined different levels and make the error percentage lower at the beginning and then or higher, lower at the beginning or higher for the upper levels. So that makes a chance that the AI makes it more difficult. So our next implementation is called AI with reaction time and maximum speed. Pretty much we're going to be defining, let's first copy the function. Again, we're just going to be changing the contents of the AI movement function. So again, it receives a paddle in the ball, but we are defining also a max speed of 5 in this case and a reaction time of 2. So first of all, the first major change that we are going to do is that AI is only going to move if the ball is inside the right side of the screen. So if the ball is inside the right court, which corresponds to the AI, then the ball is going to move. If not, then the ball is not moving. We'll be establishing what is the ideal position for the paddle to align with the ball. We'll be calculating the distance between that ideal position and the current position. And using that distance, we're going to be simulating some reaction time. So if that distance is greater than the reaction time, so let's say, for instance, the distance is 3, and we currently have defined the reaction time as 2. So we're going to be slowing down or increasing the distance to be slowing down the movement of the AI. Again, we're going to be doing the same thing to limit the speed of the AI. We're going to see if the distance is also greater than the max speed. In that case, we are going to be also changing the distance to make the AI slower. And of course, we'll be checking also if it's inside the bounds of the screen. Let's now play against this AI. Again, controlling the left side. Also not easy for me to hit the ball, but as you can see, the AI is moving very slowly. Not just moving slowly, but also reacting slowly, because for one point, it only moves when the ball is on the right side of the court. And also due to the reaction time and the speed, it does not move very fast. So this, depending on the ball position, it increases the difficulty of the AI to hit the ball and makes it easier for the player to play against the computer. Of course, you can adjust the max speed and the reaction time to make it less complicated or more difficult for the player to play against the AI. So bottom line, making the AI more difficult to play against. So our last implementation is called the AI predicts ball position, because that's precisely what we're going to do. So first, we're going to be, again, replacing our AI movement. Now we're going to be having two different functions. So we have still our AI movement that receives the paddle and the ball, but also receives a ball direction. So that means that we're also going to be needing to change our game loop. So I copy the code for that. So inside our game loop, which before was just calling AI movement with the paddle in the ball, so now it will also be needing to pass the ball direction, and this ball direction is needed because now we're going to be trying to predict the ball direction, because before we were just matching the exact position of the ball, but now we're going to be trying to predict where the ball, the direction that the ball is going. So again, we have our AI movement. Again, it will only move it if it's on the right side of the screen. Similar to the previous implementation, we're going to be establishing what is the future position of the ball, and again we'll be calculating our distance based on our current position. The difference now is that we'll be using this function that we are implementing to predict ball position, which receives the ball, the direction, and also the paddle width. So we'll be first calculating the time that it takes for the ball to reach the AI paddle, and then we'll be calculating the ball's future position based on the direction, and also obviously the time that we need to reach for that direction. And this is returned to the previous function. So the future position is going to be filled in from the AI movement. It's going to be filled in with the output of that function. Again, as before, we're going to limiting the speed at which the AI can move. So if the distance is bigger than the speed, we're going to be slowing down the AI. And we'll be moving the paddle in terms of the distance as before, but we're also checking if it's inside the screen bounds. So let's now play against the AI and see how easy it is to play against this AI or not. So very similar to the previous implementation. So the AI only moves after the ball crosses to their side of the court. But different than before, instead of exactly matching the ball position, now it's going to try to predict the ball position, and it's still limited by which speed it can move. So even though taking the ball direction, it can predict it, given the speed that it can move, it might not have enough time to move that distance to catch the ball. So as you can see, it can catch the ball, but depending on the exact position, might be difficult for the AI to catch. And that concludes our episode for today. Like the video if you like these different implementations, or if you like the video in general, and subscribe if you want to see more content about Python and Django, and also of course more PyGame content in the future. Thank you for watching, and in the meantime, happy coding!